this video we're going to be looking at GCSE Physics velocity time graphs. Question 1a, describe in detail the motion shown in the graph on the right. So A to B, we have uniform acceleration. We can see that by the constant gradient in the graph. Remember, this is a velocity time graph here that we're showing, so this must be showing the acceleration as the gradient. From B to C, we have uniform velocity. The velocity is not changing, it's remaining at 5 meters per second. C to D, again, we have uniform acceleration here because it's a straight line, constant gradient. And from D to E, the gradient is increasing sharply, it's curving upwards. And that shows that there's non-uniform acceleration. In fact, the acceleration, you can go further to say the acceleration is increasing. Part B, what is the distance travelled in the first 40 seconds? So 40 seconds, 0 to 40 there, that's the first 40 seconds. So the distance travelled is the area, total area under the graph. So we've got the area of a triangle here and the area of a rectangle here. So we have to add up those two areas. So the way we do that is we look here for the area first of all of the triangle is a half times 10 times 5, so we've got a half times the base times the height plus 30 times 5 of the area of the rectangle. So this is 30, 10 to 40 is 30 seconds times the height, which is 5, equals 175 meters in total. See, what is the acceleration in the first 10 seconds? Acceleration is the change of velocity divided by time, is 5 divided by 10, 0.5 meters per second squared. D, estimate the total distance travelled. Now it's saying an estimate because this is curved, this part of the graph from D to E. There's a curvature as we've just seen. So if they were all perfectly straight lines, like they are in A to B, B to C, C to D, if D to E was also a straight line, then you could work it out, you could calculate it using the same way as we calculated for part B. But we have to estimate now because it's curved. So what we mean by estimate is how much proportion of this square do you think is being taken up? Well, that's about a half, isn't it? It's about half a square. And this square, well, it's about 3/4. This square is about half. This square plus this square is plus that little tiny bit there is probably adding up to about half a square. So there's half a square, there's half a square, there's 3/4 of a square. So that's 1 3/4 roughly. So as long as you go like that, you're going to be fine. So we've got this area of 175, which we calculated in part B. That's all the way from A to C. Then you've got this area in here, which you've got to calculate. So there's a half times 25 times 3, and then plus this 5 times 8, and then plus a half times 5 times 5. So that gives 290 meters. See if you get the same one if you do that. Do you think it's an under or an overestimation? So this would be an overestimation because we're taking through the dotted lines, you see. So this is my estimate here of you put in dotted lines here to take the area under that dotted line. So that's what you've got to do when it's curved. Fortunately, we don't have to do that here because it's straight lines. What is the average velocity? Average velocity is distance divided by time. 290 divided by 70 gives 4.14 meters per second. Let's go on to question 2, stock car racing in the mountains. So this shows the velocity time graph of a stock car racing in the mountains. How long did he wait before the starter waved his flag? So it's stationary from A to B, so we're going to assume that's what it's talking about, so 10 seconds. Part B, is the acceleration greatest at B, C, D or E? So we're looking for the steepest gradient, which is here, okay, at C. If you look at D, it's less steep gradient, still quite steep, but not as steep as C. And at E, it's basically flat, so no acceleration going on there. But see, at which point does he cover most ground per second? So most ground per second, we're looking at the greatest velocity. So that is E, biggest velocity, 50 meters per second. D, what is the maximum velocity? That is 50 meters per second. E, when do the brakes go on? It's at E, so from B all the way up to E, there's a changing speed and he's traveling forwards in time and in distance, and then at E, his velocity starts to decrease because he's put the brakes on. F, how long has he traveled when he starts to brake? So that's the area up to, under the curve, up to E. So that would be the distance, but the question is saying for how long has he traveled when he starts to brake? Well, he brakes at 50 seconds. Okay, but however, that's not quite right because he only started at 10. He started at 10 seconds. So he started at 10 seconds and then he went to 50 seconds. So that should actually be 40 seconds. Part G, when does he hit the other car? He hits the another car at F and his velocity drops right down to 0 in very short time, almost instantaneously, we can say. Part H, for how long does he stand still after he hit the other car? So between 80 and 100 seconds, so that's 20 seconds. At which point does he start to reverse his car? So he's going backwards, negative velocity here, so it's point H, he starts to reverse. What's his maximum velocity in reverse? It's down here, so it's about 7.5, halfway between 5 and 10. How many seconds does he reverse his car? So he's reversing all the way from H to J, so from 100 to 140 seconds, so 40 seconds. In your own words, explain the difference between speed and velocity. Well, however you want to put it in your words, but you could write speed is the rate of change of distance, velocity is the rate of change of displacement.